Hello, and thank you for joining us. This course provides an overview of the important factors that need to be considered when selecting and specifying a railing system for a commercial or residential project. At the end of this program, you will be able to identify common railing materials and finishes and compare their performance in order to choose materials that best suit the structural requirements, style, and environment of the project. Recognize the unique benefits of different railing materials with respect to durability and sustainability. Distinguish between a variety of railing fabrication, assembly, and installation methods to ensure a safe and attractive railing design. And finally, understand relevant building codes and standards related to the structural integrity and safety of a railing project. Introduction to railing. What defines an architectural railing system? A railing system is a combination of any number of horizontal, vertical, or inclined members or panels that together create a framework that's located at the edge of a floor opening, stair flight, ramp, or platform. A handrail may be part of a railing system, but may not necessarily be the top member. A handrail may be connected to the system or mounted to a wall or other structural element. And of course, it's used to grasp by hand for support when users transition from one area to another. Architectural railing systems offer durability, strength, and design flexibility for indoor and outdoor applications of commercial, industrial, and residential structures. Standard terminology of railing systems. Now, before we delve deeper into our railings program, let's take a closer look at some key railings terminology to provide both meaning and context of important technical terms for both the expert and the non-expert user. Railing terms. Baluster, one of a series of closely spaced, upright, and parallel infill members of a balustrade, located between the top rail or handrail and the bottom rail or tread or floor beneath the balustrade. Balustrade, a railing system consisting of a row of balusters capped by a rail or handrail. Cap rail, a secondary railing element, often a handrail, fastened to the top rail of a railing system. Easement, the curved portion of a rail and handrail forming a transition in the vertical plane between the horizontal and inclined sections of a handrail. Escutcheon, a protective or ornamental cover located at the termination of a post, baluster, or rail against a tread, floor, or wall. Synonym for collar, cover, flange, cover plate, or cover ring. Finial, an ornamental piece on the top of a post, newel, or railing, frequently in the form of an urn or pineapple and so named. Flange, a flat plate or disc at the end of a railing for attachment to the adjoining construction or supporting member. A floor flange secures posts, columns, and newels to the floors of buildings. Guardrail system, a railing system providing protection against accidental fall and injury located at or near the outer edge of a stair, ramp, landing, platform, deck, balcony, hatchway, manhole, floor opening, porch, or accessible roof, or at the perimeter of an opening or accessible surface, such as the opening of a stair. Handrail, a horizontal, sloping, or vertical member normally grasped by hand for guidance or support. This member may be part of a railing system and is often, but not necessarily, a top member, top rail, or may be mounted on a wall or other building element. Handrail bracket, a device attached to a wall, post, or other surface to support the handrail. Infill, a series of balusters with panels, mesh, or similar elements, serving as a structural and/or decorative element located between top and bottom rails and posts to serve the twofold purpose of protecting bodies from penetrating and falling through the baluster and panel infill areas, and providing a specified resistance to horizontal thrusts as are potentially encountered within the infill area. Infills should be designed in such a way as to deter climbing of the railing system. Newel, a decorative or structural post member at the start or end of a stair run, often extending above a handrail, usually square or rectangular in cross-section, supporting the end of a stair railing or serving as the common support for two stair railings, often supporting a stair stringer and platform. Also, the center post of a spiral stair. Railing return. A bend at the end of a handrail, turning toward the wall or post to which the handrail is attached. Railing system. A framework of horizontal, inclined, vertical, and infill members, including panels and grillwork, for protection of building occupants against fall or injury, and for offering safety and convenience in their movement. Tubing. A hollow section of metal or other material having a round, square, rectangular, or other cross-sectional form, its size being designated by outside dimensions and wall thickness in inches or millimeters. A well-designed railing system not only offers support, safety, and accessibility, it also enhances the aesthetics and visual appeal of a building environment and affects how users interact with the structure. Let's talk a bit about selecting the appropriate railing. Not all railing systems are suitable for every building project. Many factors must be considered before selecting a railing design for a specific location and application. And this course takes a closer look at these factors. All factors should be evaluated together in order to best determine what type of railing should be specified for a particular project. Basically, the criteria for selecting the appropriate railing system should include, but not be limited to, the environment and geographic location, the type of building and its intended use. In other words, is the building residential, commercial, or industrial? And who uses the building? Is the building a medical facility, a school, a residence? The scale or size of the project, the materials including performance, maintenance, and aesthetic considerations, fabrication, installation methods, and mounting conditions, and finally, building codes and structural requirements for safety. Let's now take a closer look at each one of these factors. Environment, geographic location. The environment and geographic location of a railing project may dictate its material selection, including the finish or coating. For example, is the climate humid? Humidity can speed up aging and corrosion. When the climate is humid, a more corrosion-resistant material is required, especially for outdoor railing projects. Salty air creates a harsh environment for railings. Railings in locations near saltwater or adjacent to a marine environment, such as a bay or ocean, should use a corrosion-resistant material both indoors and outdoors. The material finish must also be appropriately evaluated. We'll discuss the durability of specific alloys, such as stainless steel 316 and anodized aluminum, which are commonly used in these environments later in this course. Are high winds prevalent in the area? Railing systems that are subject to high winds must have a high structural load-bearing capability and should be tested to withstand a specific load. The testing should also take into account how the railings are installed. Additionally, maintenance requirements may vary depending on environmental conditions and seasonal weather variations, such as extreme hot or cold, high rainfall, and other conditions. Intended use. Let's now discuss the building type for a couple of minutes, as it can affect the railing design in a number of ways. Different factors come into play depending on whether the railing project is being installed in a commercial, residential, or industrial setting. A residential railing installation is subject to code interpretation that relates to residential living, such as the presence of unattended young children or the elderly, who rely on handrails for balance and stability. The unique tastes and sensibilities of the homeowner or the design requirements of the developer will be an important factor driving the overall design and aesthetic of the railings. Commercial railing installations are subject to more stringent code requirements, and this will certainly affect the design of the railing system. We'll dive deeper into building codes later in this course. The railing design, style, and finish should be consistent with the overall aesthetic of the project. Additionally, some buildings require the use of building materials that aim to promote a clean and healthy environment. Railings made of antimicrobial material or finished with an antimicrobial coating may be required in healthcare facilities, food processing plants, hospitality buildings, and transportation service locations. And keep this in mind, railings in high-use public facilities such as hotels, schools, and shopping malls may require more frequent maintenance. Industrial railing installation may not be subject to the same strict code interpretation as commercial installations. Railing design is often a secondary consideration that is preceded by practicality. Generally speaking, specific finishes or colors will be utilized for easy identification, for example, yellow or red for safety. It's important to note that an industrial environment is usually subject to limited access by adult workers with safety equipment. Other factors to consider regarding the intended use of a railing system. Is the railing meant to enhance a space as an architectural centerpiece? Does the railing need to offer an unobstructed view while still providing a safety guard around a balcony, deck, or staircase? The size or scale of a project could influence the type of materials or fabrication methods used. For instance, small handrail or footrail projects can often be designed and fabricated from stock components. Depending on the manufacturer, some may be sold as kits that include all the necessary components and installation instructions. Large railing projects may benefit from the installation of pre-engineered railing modules, such as prefabricated posts and prefabricated infills. Railing materials. Railings are fabricated from a variety of different materials. Each material offers its own unique aesthetics and advantages. The most common materials used for railings are wood, PVC plastic, stones and concrete, metals. Wood is valued for its beauty and flexibility. It's plentiful as a resource and is available at local lumber yards and distributors. There are many varieties with distinct natural grain patterns to enhance design. The simplest hardwood may be stained or painted without adding excessive cost to a project. Wood is very versatile. It can be handcrafted for a rustic look, carved for a more traditional look, or combined with other materials, such as stainless steel, for a modern look. Interior wood railings can be cleaned and maintained fairly easily. However, outdoor wood railing systems require regular, ongoing maintenance to prevent deterioration or rot from exposure to the elements. PVC plastic. PVC railing systems are considered low maintenance as they are not subject to the decay or corrosion of natural materials such as wood or metals. However, in some geographic locations, the sun and extreme hot or cold temperatures can affect its appearance and longevity. The posts are commonly reinforced with aluminum or steel, and with today's metal-to-metal connections and hidden fasteners, the aesthetics of the railing systems remain intact. Stone, concrete, marble, and granite. Stone railings have been around for thousands of years. Railing installations that utilize materials such as natural stone, concrete, granite, or marble are appropriate for certain architectural styles. The cost of these materials varies depending on its source and rarity. Please consider that special handling is required in fabrication and installation, as stones are heavy and fragile. Metals. Metal railings are widely used because they complement many design styles, are readily available, and are cost-effective. Over time, manufacturers of metal railings have developed a vast array of components, fastening brackets, and fittings that make metal railing systems extremely flexible, attractive, and quick and easy to assemble and install. Easily combined with glass, wood, and other materials, metal railings have a leaner profile than wood or stone, but offer greater strength. Common metals used in the fabrication of railings are aluminum, brass, iron, steel, and stainless steel. Aluminum. Aluminum is a non-ferrous metal that is lightweight, strong, and known for its resistance to corrosion. Aluminum railings can be powder-coated or anodized to meet the aesthetic requirements of a project, and over the long term require relatively little maintenance. As a railing material, aluminum offers ease of fabrication and versatility in design and installation. Aluminum is used in outdoor applications such as decks and hotel balconies since it is resistant to corrosion. Aluminum tubes are available in a large variety of shapes through a manufacturing process of extrusion. This process pushes or pulls the material through a die to create tubing that can have very complex cross-sections or shapes, which can increase the strength of the shape. It can be easily cut and welded, and many fasteners and fittings are readily available, making it an effective material to use for building railings. Brass. Brass has been a favored architectural element for centuries, and it continues to be chosen for classic railing installations that feature traditional design, such as grand hotel lobbies. Solid brass is usually polished to a bright glowing finish, revealing a deep, rich color. However, polished brass will tarnish over time and needs to be maintained regularly. When solid brass ages naturally, the tarnish transforms into a warm patina finish, desirable in certain architectural decors. Brass alloy is made of copper and zinc, but may also include small proportions of a range of other elements including arsenic, phosphorus, aluminum, manganese, and silicon. Brass has higher malleability than bronze or zinc. The relatively low melting point of brass and its flow characteristics make it a relatively easy material to cast. By varying the proportions of copper and zinc, the properties of brass can be changed, allowing hard and soft brasses. Aluminium makes brass stronger and more corrosion resistant. It also